All right, welcome to Honors Physics Lesson 1.4 on acceleration. And a nice little gift that I have for you here is a Mustang, just chilling, driving around, all kinds of change in velocities, all kinds of acceleration. It's from Need for Speed, the movie. I like Mustangs a lot, so if you want to get on my good side, tell me how awesome Mustangs are. All right, anyways. Back to what we were doing. So when velocity is not constant, so up until this point, velocity has been constant, or we've been only looking at instantaneous velocity. But when it's changing, we have something called acceleration. So acceleration is the rate at which the object's velocity changes. Get that out of there. And that's given us by the formula of velocity final minus velocity initial over time. So the change in velocity, how much it's changed by over how much time it took it to change. And the units for that are going to be meters per second, also known as meters per second squared. All right, so go ahead and look at our first example here, a Mustang example, so you know it's sweet. A Mustang can go from 0 to 60 miles per hour in 5 seconds. What this is measuring is the time it takes the car to increase its speed from dead stop to 60 miles per hour. So we have our Mustang, it's speeding up. What's its acceleration? It does so in 5 seconds. So there's a couple ways that you can go about this. I'm going to want the answer for this one in meters per second squared, since that's what I said our units are going to be in. So we're going to have to do a little bit of conversion here. First thing you could do is convert the 60 miles per hour into meters per second. So for every 1 hour, there's 3,600 seconds. For every 1 mile, there's 1,609.3 meters. So this should be, calculator out, 26.82. 6.82 meters per second. All right, so that's our final velocity, and we do that over 5 seconds. So our velocity initial equals 0 because it was at a stop. Velocity final equals 26.82 meters per second, and our time is 5 seconds. So going back to our acceleration formula, our acceleration should equal 26.82 minus 0 divided by 5. So it should be about 5.1. I'll go to the 100th spot. So acceleration equals 5.36 meters per second squared. The other way that you can do this, which may or may not be easier, there was a little bit of confusion here. Second way is you can go ahead and take that 60 miles per hour and divide that by how much seconds you have, and that would be 12. I don't know why I was thinking 8. That was dumb. Sorry, I apologize. 12 miles per hour, and this is the tricky part, per second, right? Miles per hour, and then divide the whole thing by seconds. Then you would have to convert that the same way that we did over there. So hours on top, for every 1 hour, 3,600 seconds, and for every 1 mile, we have 1609.3 meters, and you'll get the same answer, which is 5.36 meters per second squared. So either way is fine. I find that this way sometimes gets people a little bit more confused because you're dealing with per and per. If it doesn't, hey, more power to you. I'm all for you doing whatever is more comfortable to you. So let's look at this one. This one you don't have to do any conversions because it's already set up for you. We have a car, it's driving 27 meters per second. The driver hits the brakes. The car accelerates at a negative 4 meters per second squared. Find the velocity of the car after 6 seconds. So I want you to try to stay away from the term deaccelerate because that indicates, or at least implies, that you are slowing down. So you can have a positive or negative acceleration. That does not mean that you are necessarily slowing down or speeding up. It all depends on what direction your velocity is changing in. So if you were going backwards, for example, and your velocity was increasing in the backwards direction, in other words, becoming more negative, and then you were to hit the brakes, then you were slowing down, but your acceleration would be positive. So instead of be going from a positive velocity to 0, it'd be going from a negative velocity up to 0. So just something to keep in mind. Try to use the word accelerate and not deaccelerate because that could confuse you later on the road. Okay, anyways. Find the velocity of the car after 6 seconds. So I am given the time of 6 seconds. I'm given velocity initial, which is 27 meters per second, and I'm given acceleration, which is negative 4 meters per second squared. So negative 4 meters per second squared equals VF, what we're looking for, minus 27, what we started with, divided by 6. So multiply 6 on each side, so we have negative 24 meters per second. Right? The seconds multiplied would cross one of those out, equals VF minus 27. Add 27 to each side to get rid of it. Velocity final then would be 3 meters per second. So we didn't actually stop. We are still moving at 3 meters per second. So we slowed down considerably, but didn't stop. All right, real fast. Acceleration is a change in velocity. So anything that changes acceleration changes, or anything that changes velocity gives us an acceleration. So speeding up, slowing down, or turning, right? So good stuff to keep in member. I will see you next time, next place. Hopefully I won't garble my words as much. I apologize. I don't know. I've had too much coffee and now I'm crashing. Okay, talk to you later. Goodbye.